Good morning, everyone. Thanks for joining us this morning. So today's presentation topic is DNP configuration for our latest Shark 250 and Shark 270 models. Before I go into detail about the configuration, I would like to cover some basic overview about the DNP protocol. So DNP protocol is mainly like a utility substation protocol. What I have seen so far is like utility would use it to bring in real-time communication data or alarms from different devices. It could be meters, it could be relays, and so on the substation. And all our meters, including Shark 250 and 270, they have a DNP support. Shark 250 and 270, they have a DNP level 3 support, which means it supports all the available parameters that meter has been recording, along with the alarms and the thresholds that you can bring in through the DNP protocol. We do have DNP parameters listed on our manual, so I'll just quickly go through where you can download the information from. So this is our website, electroind.com. And if you go under products and you go under the Shark 250 or 270, this is our Shark 270. The basic difference between the Shark 250 and 270 is the form. 270 is our socket form meter, 250 is the panel mount meter. And in terms of capability and the functionality, they are same. So for this presentation, I'll be covering Shark 250 mainly, since the configuration will be the same for both meters. So let's say we pick Shark 270, and on the right, that is the tech documents. And if you download the user manuals, I already have it downloaded, so I'm gonna show you this. This is the user manual for the Shark 270. And DNP configuration starts with Appendix C, which is on the page 322. So we start off with a little bit basic of what are the functions available on the DNP. So the way the DNP protocol works is there are points or parameters that's defined in the different groups. They call it objects. So for example, there is object 30, which is an analog input, object 20, which is a counter, and so on. So we talk about those configuration on the manual. Also, DNP has multiple groups in terms of like class 0 through 1, 2, and 3. So that you can also configure on the meter setup. I'm just going to quickly show you what's the informations are on the manual, so you can quickly browse through it. There is different variations that we support. That's all listed in the manual. When we say variation, the DNP thinks variation in terms of a data type. So for example, binary counters could be integer as a data type, which is one of the variations, and so on. I'll go into much detail when we go into the actual meter setup. So this is all the information when you about what functions or capability meter supports, especially for Shark 270. Now, to configure the meter for the DNP setup, you need to use our Communicator EXT software, and that you can download from our website also. If you go under products, there is a software, Communicator EXT here, Communicator PQA. So for this presentation, I'm going to be connecting to one of my meters installed here at the factory. So I'll launch the communicator. And connect to the meter. So I have the meter's IP address. Connect. It shows me the basic information. This is a SHA 270. We have the meter serial number, meter type, firmware information. I'll click OK. And any configuration, any changes you want to make, that's done through the profile. We have another webinar that went through the details of the profiles for the SHA meters, but I'm going to quickly go into the SHA 270 DNP configuration only. So this is how the profile looks. On the left, we have the tree menu where you can scroll through different options, and DNP configuration is right under the general settings. So SHA 270 supports DNP over serial, which is RS-485, and it can have DNP over Ethernet. You can have both type of communication. We have some customer, they want to use one DNP over RS-485 going to the one RTU, and another DNP over Ethernet going to a PLC, which is being pulled by a SCADA system or something. So you can have simultaneous connection for both. To configure this DNP settings for the Ethernet, since I have the Ethernet card installed, you go under the option 1, which is a network card, and there is a DNP section here. So here you can choose the DNP protocol port number, which is 20,000 as a default, device address, which is 1 as a default. Also, we allow security for the DNP protocol. So sometimes what happens is, let's say you have multiple masters, multiple DNP softwares on the same network, and you want only one of the software to be able to talk to the meter. You can put in the IP range of the IP address for that masters to be allowed to be talked to the meter. Same thing, we have the settings for the ports. So anything within this port range can only talk to this meter. Similarly, like if you're using DNP over serial protocols, you would go under the configure serial ports, and this is the RS-485 communication serial ports, and you pick the DNP protocols here, and so you can assign the address, the baud rate, and the response delay and the parity here. For the DNP configuration, DNP3 configuration, the first screen we have is the timeout. We have the device address. We have unsolicited responses also. So this is something we have specifically added. We did not have it in the SHA 200. We added it on the SHA 250 and 270, which is a DNP unsolicited message. So for example, let's say you have hundreds of these devices on the network, and one of the devices have any alarms, you want to get notified right away. And instead of waiting for the masters to go around and poll those all 100 devices, meter will send out a message alarm response without anybody asking for it. So this is way of generating alarms. You can select enable this unsolicited message, and you can put in the address where those messages will go through, which master they go. And there is also a timeout for the unsolicited message. Then we go under the time synchronization. So meter has a different way of syncing the time. So you can use MTP, you can use Modbus, you can use our software Communicator to sync the meter time. Some customers, if they already have a DNP masters, DNP software polling the meter, they want to use that software to sync the meter's time. For that, you can enable this DNP time sync. Let's say I want to sync it with the network. I'll just put serial on network, and I'll make sure I'll just put in 5 minutes, which is a default, to sync the meter's time. So every 5 minutes, meter will send a request to the masters that it needs a new time if I enable this. If not, it will just give a flag saying that the time has expired and meter needs to sync the time. And these are the different objects that I was talking about initially. So DNP is standard is being defined to different objects. So this is an object 30, which is an analog input. Analog input basically means all your real-time readings, your voltage, current, power, energy, power readings. Um, so on the left, we have the predefined ones. We have the voltage, face-to-face, face-to-neutral, currents, and all that's predefined. You can also put the scaling. So the scaling is mainly we use it as a multiplier. So for example, if you want the voltage to be in the kilovolts instead of volts, you can put in the multiplier of like 0.01, and that will change the scaling for the volts. Put in 0.01, yeah. So that will divide the voltage by 1000, and it will convert it into the kilo. And along with that, DNP also has different classes. So like I was saying, class 0, 1, 2, 3. Basically, class 0 is everything that's included on the meter. And class 1, 2, 3 is you define the deadband that you want to be pulled. So for example, let's say I want my voltage to be included in class 0. When I pull the class 0, I would check this box. Along with that, there is we call object 32, which is an event. So for example, let's say I want to generate alarm for the voltage whenever it goes above or below 10 volts. So what I would do is I can go into this deadband and I can put in the volts, the difference in the terms of value itself. So let's say I put in 10 volts. So whenever my voltage fluctuates more than 10 volts above or below, it would generate an alarm. And the way I could poll that is using one of these classes, 1, 2, or 3. So let's say I would assign it to class 2, which means whenever I poll class 2, it's going to give me the alarms generated for that classes. So let's say I want all three my voltage to be a class 2. I'll put in the deadband to be 10 for everything. So the idea behind this is, let's say you have a lot of those devices in your network, and you only want to poll the alarm information, the large deviations or large fluctuations. So you pick those points, let's say typically your power, kW, kVAR readings, and you assign them with the threshold or with the deadband, and you keep polling those or more frequently than class 0. So in this case, I have assigned my voltage to be class 2. Since I'm more interested in a fluctuation in my voltage, I would be polling class 2 means maybe every minute. And maybe I would be polling rest of the parameter every 15 minutes, since I'm not much interested in other parameters. Depends on your application. So similarly, like you can put in the deadbands, you can assign the class. You have up to 3 classes. You can segregate these parameters into different classes, give them a different deadband. And also assign if the parameters needs to be included into the any class 0 poll. A lot of time what I've seen customer doing is they put everything into class 0. They would poll these, maybe poll class 0 maybe every hour or top of the hour, and they would poll class 1, 2, 3 more frequently. Sometimes we have seen customer, they just want to poll class 0, and they want to do all the alarmings on their RTU or PLC. You have this functionality on the meters available. Along with this, DNP also support what I would say frozen inputs. By frozen input, what it does is basically DNP master or DNP software would send a command to the meter to freeze all the readings, or you can do it automatically. Typical application of this is, let's say you want the meter to record end of a month energy readings. You can set up the meter to do a freeze at end of a month midnight. So what it will do, it will take the energy readings, kWh, kVAR readings, which is used for billing. It will copy those readings and put them into separate registers that you can pull in once it's frozen. So you can enable those parameters. Let's say on here I have enabled my voltage, phase to neutral, phase to phase, to be enabled as a frozen inputs also. So once it's frozen, I can read it anytime after that to get those reading at that time. Similarly, we have a similar settings for the binary counters. Binary counter, which is object 20, that's mainly used for your energy readings or the counter values, your pulses, um, or pulse outputs or inputs. So you can enable the scaling for similarly like what we were doing for the analog inputs. We have the frozen counters and events where you can define the deadband or change for the delta. As a default, we have everything set up as 0, which means it's disabled. I can add any of the parameters. Let's say I want to add my counters. So Shark 250 and 270 can support up to 2 pulse input card we call. So this input card can be used to bring in the pulses from your water meter, gas meters, and you can pull those readings from the DNP side. So we have like if I have the pulse input card, I would pick the accumulators. We have like this meter, I have pulse inputs cards added on the slot 2. So I would select slot 2 and I have one card has up to 4 inputs. So you can tie up to 4 meters, 4 pulse meters into the Shark meter. So I also assign input 1 accumulator as my DNP point. So on the left, you have the point list. So when I pull my DNP, I would know that point 0 on object 20 is my energy, scale energy, watt hours delivered. And point 5, it's my input 1 accumulator. And let's say I want to assign it to class 0, I'll check the box. And if I'm using frozen counters, I would enable that. Similarly, I have the delta for the events. Now, when I was talking about initially about the freezing the registers, you can also enable this auto freeze. So like I was taking an example, let's say you want to freeze these registers on the monthly basis. I would pick this monthly, let's say you want to freeze it on the midnight. Then you put it these settings. Some customer, they want to freeze these registers on the daily basis also. So like we have some utility customers, they want to freeze the energy reading on the midnight every day. So next day they go in and read those energy readings to calculate the daily consumptions. So you can do the similar thing, like you can enable the daily at the midnight. So at that time, meter will copy all those registers and put it into separate sets, separate section of the memory. Binary inputs. So let's say you had the pulse input card added onto the meter. You can check or uncheck the points that needs to be included by the pulse input for the pulse input card. Similarly, we also allow control over DNP. So let's say you have you want to reset some parameters on the meters. So let's say your energy counters, max min, your demand readings. You can check these boxes. So your DNP software or DNP master can send a command to reset these registers on periodic basis. So let's say example is similarly, once you on top of the month, you want to reset the energy readings or the demand readings of this meter, you can do it through the DNP masters also. There is also some strings that you can include for the DNP. So like we have some customer, they want to poll the meter serial numbers, meter name, or maybe you can put in your own string to set up, let's say, your account name or account number where the meter is located. You can add your all this information. Let's say this meter is located on substation A or something. So along with the DNP registers, DNP readings, meter would respond back with this information to help you diagnose where this information is coming from and so on. Along with this, we have a different variations that we support. So for example, um, analog inputs, which is our object 30, is basically a floating data type. But we have run into some customer, let's say their RTU or their PLC is old, they cannot support all the variations that meter has. We allow you to change these variations. So let's say I'm using RTU that only supports 16-bit. Then I will just select the 16-bit for object 30. So meter will use that when there is no variation defined by your master, and it will use as a default variation and respond all those data points as per this variation defined on the profile. And once you are done making all these changes, what you can do is you can go ahead and do update device, and that will load the settings back into the meter along with all these DNP parameters. I have already done this, so I'm not going to update the device. For DNP polling, what I'm using ASC test set, which is pretty much standard for the utility world for testing of the DNP protocol configuration. Of course, if you like, this is just for the testing. If you have RTU or PLC, you'll be using that to poll the meters reading on the continuous basis. I use this just for the verifying the meters setup and the DNP communication. So the way this software works is first you define the select the protocol. So since in this case, I'm using DNP over Ethernet, I'll pick DNP over LAN WAN. Then under properties, you can define the IP address for the DNP. So this is my IP address for this meter, 172.20.167.168. Then I have the port number, which is 20,000 as a default. I'll click OK. So now you can see on the left side, I'm seeing the similar option that I was seeing on the meter profile. So for example, I had the analog inputs, analog output, all those events are as one of the options to be pulled from the DNP software. Along with this, I have different classes, class 0, 1, 2, or 3, or you can use class 0, 1, 2, 3, which is basically an integrity poll. So that will poll everything that's being set up on the meter. So just for the testing the protocols, I would just use this. So I'll double click on this. And here is where you can put in the address, DNP address of the meter. So in my case, I put in DNP address 1. So this is my destination address. I'll click OK. Now if I want to run this, I would highlight it and hit send once. And so this is the communication request and response from the software and the meter. And on the right side, it shows me all the points and the values for that point. So to compare this, let's see how the meter is set up. Then we can look into the parameters. So similar to like a Modbus, if you guys are familiar, DNP doesn't give you the description. So you would have to look at how the meter is set up in terms of what points and the line and points for each object, and then determine what you are receiving on the DNP side. So for my example, I'm taking this analog input as an example, and I have first point set up as my volts A to neutral, which is my point 0. So when I go into my DNP, I can see my analog input 1, which is my, let's see, what's my analog input 1, which is my B to neutral voltage, and it's reading 14359. So let's say if it matches with the meter. So let's say I click OK, cancel. So this is our software readings, which is showing me real-time voltage. So my B to neutral voltage is around 14 kV, and which seems to match with my DNP DNP point. Similarly, like rest of the points, you have the currents. Yeah, and next 3 points are my line to line voltage. You have my currents. We have the frequency, 60 hertz, and so on. So like I was saying, this is bringing in everything that I have set up on the meter, along with counters, which is my energy readings and so on. So let's say how do I have my counter set up. So these are my binary counters. The first point is watt hours, then delivered, received, watt hours, VA hours. So DNP would respond with everything that's set up on the meter. I can poll this separately. Also, like I have option to poll just the analog inputs. Let's clear this. And let's say I want to poll my analog input. So now it's showing me only the object 30, which is my analog inputs and the setup for that. Along with this, I have option to poll individual classes. Let's say I want to put class 1 only. So I would highlight class 1, I put in my destination address and send. So here's the thing about the classes. So if the meter does not have any events, it will not respond. So like I was talking about initially, when you only want to get the information or the parameters when there is an alarm. So if there is no alarm, meter will not respond, and so we can keep polling this class 1, 2, or 3 every so often, maybe every minute or every 15 minutes. That will, if any of the meter has any alarms, that any parameters that went out of the threshold that you have set up, then only meter will respond. Otherwise, meter will not. Meter will say there is no data, or it will respond with the acknowledgement only. Similarly, you can also do a freeze command. So like I was talking about on the meter profile, where you can set up auto freeze to freeze the meter registers on a daily or monthly basis. I can do the similar command using my DNP masters. So I can send a freeze command from my software to freeze all those meter registers and copy them into a different section. Along with this, we also support relay objects. So let's say your Shark 250 or 270 has a DNP, has a relay card. One relay card can support up to 2 relay outputs. you can use those relay to control some equipment. So for example, we have some customer using the meters to do a demand control. They turn off equipments based on the demand. Sometimes they use the meters to do a power factor control. Whenever their power factor fluctuates above or below the threshold, they want to turn on the capacitor banks. We have some customer, they want to use the meter to control their solar panels. Whenever they are generating more than their usage, they want to turn off their solar panels so it doesn't push the um, power back into the grid. So you can do those controls on the meter itself. You can set up the meter to do relay trip based on the set points that you defined. Also, if you want to trip a relay manually from the DNP side, you can do this DNP relay control and use that to trip a relay, any specific relay, and that will do the that will do the control on the site. So that's where I see the option for relay, operate relay, and so on. And similarly, we have the binary inputs or outputs, which I can use for my counters. I can pull it to read energy readings or pulse inputs or outputs. And a lot of time what I have seen with the customers or issues so far is like when they do not have the security set up properly, or the network is blocking the port 20,000. So typical issues we see, like when the customer try to pull the DNP, they don't get any response from the meter, or the data they get doesn't equate to the communicator or the meter's display. What typically is you want to make sure is you have the port set up. Let's say your network is blocking 20,000 port, you can change the port number. You can make sure the IP address this is within your net within the range of the IP address that you have put in on the meter, and the variations that you define for the objects. So for example, if you're using analog object 30 and I have it defined to be 16-bit, it's going to truncate some of the parameter, some precision from the reading, because it's trying to fit 32-bit value into 16-bit register. So that's why you see sometimes the readings will not be exactly same as the meter display. So you would have to play around with the variation to make sure you cover the whole range of the value. Another example is, let's say your actual parameter, actual value of the register is above the 16-bit. So let's say 32767, that's the maximum value meter can represent for the 16-bit parameter. If your energy or the kWh reading is higher than that, then meter will respond saying that there is an overflow. So you can go in and adjust these variations to make sure you cover the whole range of the value that you are pulling. And that's pretty much it. I think we have covered all the basics for the DNP. And now I think we can open up the session for the questions. If there is any questions,